Uh, uh,
A very good evening everyone. स्वागत करते हैं आप सभी का आज के इस सेशन में where we are going to start our fifth installment for the lecture where we are going to talk about hashing. Okay, so today's agenda is hashing and we are going to cover one by one the topic related with hashing. Okay, so I welcome all of you in this session and let's start the session without any delay. Just give me 1 minute. Sure, let's start. So now one of the very interesting topic from this is hashing. Okay. So now what we have covered yesterday was this. We talked about yesterday with this uh, CBT, complete binary tree, and its property. We talk about max heap and we talk about traversal as well. Okay, yesterday we also talked about traversal of any tree. Okay, not only BST, specifically it was BST, but tree, binary tree to be specific. Uh, then we talked about max and min heap, max heap and min heap. Okay. Today's agenda. Good evening, everyone. Sir, I just entered first year college. Very congratulations to you. Enjoy your life. Okay. Enjoy your college life. And then sooner or later you understand that what is the idea, because we'll be keep on giving you information. We'll talk about hashing. We'll talk about collision. And we'll talk about one collision resolution technique called chaining. Okay, very simple technique called chaining. Okay, chaining. So this is the agenda for today. This is not the right place you to ask about the clear roadmap. You can get a lot of videos on that. Clear roadmap. Okay, let's start with this. Huh? So now one of the technique for, let's say, searching. Okay, searching is one of the very important operation. Searching an element in a data structure. Okay, searching an element in data structure, in any data structure, it is an important operation. important operation, searching. And if you look at the syllabus of algorithm, then you will find, good evening all of you again one more time, then you will find that searching is mentioned, searching and sorting has been mentioned in the algorithm. Okay, so searching is one of the very important operation, and one of the idea that has been proposed for increasing the time complexity, that means faster searching, is idea that is proposed is direct addressing. Okay, direct addressing, and this idea is proposed for making best time complexity for the search operation, direct addressing. That is linear and binary search. We will not go into that, we will directly come to hashing, and we will also understand how hashing came into the picture. Okay, how hashing came into the picture. So one of the core idea is direct addressing. There it started, hashing started from here. What is the direct addressing? Now the direct addressing uses two things. Direct addressing uses two things. First is a large size array. Okay, a large size array, simple data structure array. And second, it uses it arranged element such that it arranged, first you understand the key idea, arranged element such that the index of the array, index value 0, 1, 2, 3, index I told you in array. When I covered array for C programming last Friday, there I told you the index. So index of array represent the key value. Now to understand this, what is the meaning of index of the array represent the key value? Key value is the value from which we are performing the search operation. So suppose this is the array, and this array index represents 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, suppose 11 elements are there, 0 to 10. So if you want to, we are arranging the element in such a way so that index represent the key value. These are the indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the index value. And if you want to search 7, it's a very trivial question, how I can get the data whose key value is 7? Okay, how I can get the data? How can I get the data with key value, with the key value 7? Okay, how can I get the data whose key value is 7? Okay, so I want to fetch all the information whose key value is 7. How can I get the data? To very simple answer. You can do it by, you can directly access, you can that's why direct addressing. You can directly access, A7. A7. You can directly access A7, right? That is the direct addressing. Now I said a large array is required. To suppose you are searching a key value, suppose you are searching the key value 99,098. Okay, this key value you are searching. Where I'll find this data? So I'll go directly to this index 99,098 and I can access the data. So this was the this was the very simple, that was in C programming. I am dealing with a different issue here. So this is a direct addressing, but direct addressing is not practical because of the size and because of the static allocation, because of the pre-allocation. You need a large size of the array and you have to allocate all the element at once. Okay. So direct addressing is the best one. How can be in constant time? As I told you in C programming, that if you want to, what is the best thing about the array is the time required to access the first element is same as time required to access the last element. Okay, so this is same. Time required for accessing the first element is same as time required to access the last element. So that is the best part, that I can access any element in constant time. Okay, we can access in constant time. So we can access in constant time, and constant time is the best time, and it is written as order of 1. What is constant time? Order of 1. 1 operation, 2 operation, 10 operation, 10 lakh operation. Okay, so this is the best result for searching. Okay, because search is one of the important operation, and this is the best solution. Okay. Yes, you can apply. So this is the best answer, but it is impractical. So rather than making it practical, they have proposed, let's say, another solution. Okay, because it's not practical because of the size, and mandatory you have to allocate everything. So what they propose is that, okay, direct addressing is a good idea, but it is slightly impractical. Let's have a small size table. Let's have a small size table called hash table. First you understand the fundamental idea about hashing, then we can talk about other things, collision and all. So let's have a small size table called hash table. Okay, let's maintain a small size table that is called hash table T. Let's maintain another table T, and this table is like an array only. Index from 0, 1, 2, 3, 4 and up to m minus 1. Let's make a small size table. Rather than storing k is equal to 3, what direct addressing was doing, if k is equal to 3, then the data will be stored here in this position, k. K will stored in third position only. Okay, understand the idea that direct addressing was doing. Okay, that direct addressing was doing the idea that if k is 3, then this key value will be stored in direct addressing in third position. Here k will go. Why? Because the key value is 3, right? Okay. So now rather than storing into this 3, somebody please advise, suggest him that how can he access the nodes. So rather than storing the value k into third position, which is basically direct addressing, we maintain a function mapping, a function that compute the index, that computes the index value, that computes the index value. Like, rather than storing h, first we will you give key, will give it to a function, and that function is, let's say, hk, and it will give you some index. Okay, some index it will give you, and it will store in that index. So understand the difference between the two approach. In direct addressing, we are going to store, if this is the key value, it will go to a of 99098. But in this, what we are doing, I will input the 99080 into this function, and this will give me the index where it is going to be stored. Okay, where it is going to be stored here in this cases. Fine. So this is the idea. So this is called a table, which is called a hash table, and this is a function like normal function. This function is called as a hash function. Okay, this function is called as a hash function. So now for this, there are 3 aspects are there for this hashing. What we are having is some keys, some key value k that we want to store. Okay, that we want to store, another is T, that is called hash table, and there is a HK, that is called as a hash function. Okay. Now let me demonstrate that how it is been done. Okay. So this is the idea of the hashing here in this case. Hashing is one of the very important concept, and this is the only data structure which is supported by your Java. It means there are hash you can include in every programming language supports this. And the main operation application I already told you, if it is used heavily in searching, okay, so anywhere that you are searching, even like searching Google search, search operation is happening over there, try to see that what algorithm that it uses. Anywhere searching operation, even if you are searching a catalog, if you are searching for a book, if you are searching for a, let's say, a product, you are giving the key value and you are finding the product over there in this, so that in that case it is used. Now before I go to this particular problem, let me say discuss how it is implemented. So let's see one function over here, that how does it implement, before I proceed and I tell you where it is used here in this cases. Now suppose this is the hash table of size 10, so table of size 10 is there. Okay. Now suppose HK is equal to, the function is k square modulus, modulus 10. Okay, the function is k square modulus 10, k square modulus 10. Now suppose I want to hash the keys, hash the following keys. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I want to fill this table by of size 10, and I want to use the hash function k square mod 10, and it may differ also. Okay, so now here if I say h of 1, so that will become 1 square modulus 10, and that is equal to 1 only. So 1 will go into the position 1. Okay. Now if I say 2, h of 2, that will become 4 modulus 10, 2 square modulus 10, and that is equal to 4. So 2 will go to the index number 4. Okay. Suppose I want to say where 3 will go, so it will be 9 modulus 10, and this will go to the position 9. So this will go to the position 3, will go to the position number 9. Okay. Suppose I want to find out where 4 will go, so that will become 16 modulus 10, and that will go to the position 6. Modulus means remainder. So now the 4 will go to the 6th position. Okay. Similarly 5, h of 5 will go to the position 25 modulo 10, and that will be going to the 5th position. So that will go into the 5th position like this. Okay, like this, all the entries you can find out. Like I have come down to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Please comment, calculate and comment that where I can store 6, 7, 8, 9, where 6 and 7 and 8 and 9 will be stored in the hash table. Am I clear with my question? Please tell me where I can store the keys 6, 7, 8, 9. Go ahead and answer. 6, 7, 8, 9. Where it will be stored? Go ahead. Great. So 6, 7, 8, 9. So h of 6 will lead into what? 6 square, 36 modulo 10, that is equal to 6. Okay, that is 6. H7 will lead into 49 modulus 10, that is equal to 9. H8 is going to be 64 modulus 10, that is equal to 4. H9, that is the last one, that will be equal to 81 modulus 10, and that is equal to 1. So your answer is 6, 9, 6, 7. 7 will go to the 9th position. 6, 9, 4 and 1. 6, 9, 4, 1. Okay. 6, 9, 4, 1. So now if you want to map here, so 6 is already is occupied. So now this is 6. 7 will go to the 9, already occupied. So 7 will be this. 8 is 4, already occupied. Yes, it is already occupied. So 8 will be here. And 9 is going into the 1, which is already occupied. So 9 will be here in this case. Now as you know, okay, as you know that two element cannot be placed into the single location. One location, one element. Array. Two elements simultaneously cannot be present in this. Okay, so now this situation is going into called as a collision. Okay, so two element present in the same location is called collision. Two element in same slot, okay, or bucket leads to collision. So two elements, same slot. Slot and bucket is what? Slot and bucket is the location of the table. Slot or bucket. What is this, sir? Bucket is location of the table. Single location of the table. Single location of table. Okay, that is called slot and bucket. Great. Okay, now the next part here that I am going to explain is one of the collision resolution technique, and that technique is called as a chaining. Okay, that technique is called as a separate chaining. So find chalo. Now, so there are two ways to resolve the collision. Two ways. One is called open hashing. Open hashing, where in open hashing and closed hashing, so we'll talk about open hashing today. In open hashing, collided key is stored outside of the table. Okay, outside of the table and they form linked list for all element mapped into the slot, mapped to given slot. Very simple. Now it may be sound confusing that how the chain is coming. Okay, how the chain is coming. So that name is, what is the collision resolution technique? One of the technique, open hashing, is outside and they form linked list for all the element mapped to given slot. That technique here in this case is called as separate chaining. What is the name? Separate chaining or only chaining. So now what we will do, we will not store, because you know that we cannot store one element into the two element into a single location. So each time there is a collision occur, what we'll do for the collided key, every key that is mapped into that slot, we create a chain or linked list. Okay, what we create? Chain or linked list for them. Okay, so that is basically open hashing. It is a situation used in dynamic hashing example. Separate chaining is an example of a dynamic hashing. Let's see how does it work. Okay, suppose these are the keys that I am mapping over here, and you will answer. There are two questions are there, which is all both are PYQ, both are PYQ, and one question was asked this year only. Okay, one question was only this year 2026 only. One of the shift they asked this particular question. Okay, so let's understand this. HK is X mod 7. So let's start with 0, 1, 2, 3, 4, 5 and 6. So 0, 1, 2, 3, 4, 5, 6. Very simple question they asked from this topic. Now the idea is 15, where 15 will go. So 15 mod 7, and now I am not calculate, I will just write the numbers here. 15 mod 7 is 1. So 15 will come to the slot number 1. 47, 5. You do the modulus, remainder will be 5. So now in this case, this is your 47. Now there is no collision till now. 23, slot number 2. Okay, 23, slot number 2. 34, slot number 6. 34, slot number 6. Now look at here. 85. 85 will go to the slot number 1. Okay, 85, if you do 85 modulo 7, you will get answer remainder as 1. Okay, slot number, but 1 already there. So what we'll do, we'll create a chain, simple. We'll create a chain and I'll store 85 here. 97 will go to the 6th position. 2 7s, 27, and 27 is 6th position. So 97 will form the chain. 65, 63 and 63 plus 2. So 2 is already having 23. So this is your 65. See, the chain is in progress. 89 will go to the 5th position. So this is the 89 into this. Okay, and finally comes the 70. So 70 will go to the 0th position. So this is how your chain will look like. Okay, rather than storing within the table, we are storing outside of the table, and outside of the table what we are doing, we are just creating a nodes here. We are creating nodes over there, and these nodes are storing the key value. Okay, so anyway, if you have any idea about linked list, then linked list is always used in the dynamic situation. Okay, it always used in dynamic situation. This is how it will look like. Okay, let's go to the one of the PYQ and answer this question, that what will be the answer for this particular question. I hope that I have written everything. Yes, K mod 9, 9 keys are inserted. Maximum, minimum and average chain length is. Okay. Find out the maximum, minimum and average chain length from this. Can you answer this question? This one. Answer it. Great. Good. So I have a very little space, but still I think I'll be able to manage. Let's have this as a table, and it is 0, 1, 2, 3, 4, 5, 6, 7 and 8. 0, 1, 2, 3, 4, 5, 6, 7 and 8. Now what are the keys? 5. So 5 modulo 9. So 5 modulo 9 is 5. 28. 28 modulo 9 is 1. So 28 will go here. 19. 19 will also go to 1. Okay, 19 is also go to 1. So 19. 15 will go to 6. Okay, 15 will go to 6. 20 will go to 2. So 20 will go to 2. 33 will be 28 plus 6. So that will go to the 6th position already there. So that is 33 for you. 12 will go to also 12, 9 plus 3, 12. So that will also go to 3 position, 12. 17 will go to again 8th position. 17 will go to the 8th position. And 10 will go to the 1 position. Okay, 10 will go to the 1 position, to 10 over here. Okay, the question is the maximum, minimum and average chain length. The maximum chain length is 3. Okay, minimum chain length is 0. Definitely some slots are empty. Okay, some slots are empty. So in this case is some slots are empty. So this is 0 length, this is 0 length, this is 0 length here in this cases. So minimum length is 0. And definitely the whole chain length 3 plus 4, 5, 6, 7, 8, 9, 3 to 5, 6, 7, 8 and 9. So total length is 9. So 9 divided by 9, that is equal to 1. Okay. So answer for this question is A. A is the answer for this question. And you can clear, I think, is it visible properly? Is it visible properly? Can you see this? Very good. Look at this question. Just a minute. Okay. Look at this question. I hope this is visible to you. Otherwise, I will increase the size and I'll make it visible to you. Find this answer, get 2026, shift to 1, though 1 mark, though 1 mark question, but still, okay, still, it's a numeric answer type, same concept resolved by chaining. What is the length of the longest chain is this year question from chaining. Please answer this one. Very good. Badhiya. Nice. Very simple topic, and the way the trend is going on, you can still get good marks into this. Huh? You can get very good, you can fetch marks from this. Now the idea is that hash table is again 9. Okay, so somewhat similar to what we have done just now. And 0, 1, 2, 3, 4, 5, 6, 7 and 8. Now 5. Okay. Now I'm wondering, is it a repeated part? Is it a repeated question? Hey, anybody just check. Is it the repeated question? Did Guwahati, has become lazy in this particular question? Huh? Just check the data also of the previous question. Is Guwahati is being lazy here? Is Guwahati becomes lazy that it is asking 2014 question here, Kharagpur question in here? Huh? Look at here, the same chain. Is it the same sequence? 5. So 5 will go to 5. Yes. 28. 28 will go to previous question. Look at the previous question. Just now you have solved. 28 will go to this. And 19 will go to this. Then 26 will be here as 26, 18 plus 8. 33 will go, as I said, 28, 28 plus 5, 26 change. Yeah? Okay. Before, I have 19 I have done, 15 I have not done. 15 is at 6. Okay. So 5, 28, 5 will be go to the 5th position. So this is correct only. 28 will be at 1. 19 is at 1. 15 is at 6. So 15 is at 6. 15 is at 6. 26 will be definitely 8. 8. So 26 is 8. 33. 33 will be 27 plus 27 plus 6. So 6 is already there. So 26 will come to the 6th part. 33 will go to the 27 and 6. So 33 will be here. 12 will be at 3. 17 will be at 8. 17 will be 8. And 10 will be at 1. Okay. So with that you can say answer for this question is 3. Okay. Answer for this question is 3. So this is one. 20 and 26 is actually though lazy attempt, though it's a very lame attempt by them. No issue. So that is the idea of what one of the technique that is called as chaining, and this is one of the probable question from this. Okay, this type of question. So this is what we have done. Now we have done. Now we'll come to the second technique here in this case is, okay, second collision resolution technique. Second technique. Yeah, go ahead. Go ahead for your doubt. Second collision resolution technique is called closed hashing. Second collision resolution technique is called as a closed hashing, and there are 3 techniques are there. One is called linear probing. Second is quadratic probing. And third is double hashing. Yeah, you go ahead and do not wait for me to see your comment. You go ahead. You go ahead with your doubt. What is your doubt? Somebody will definitely answer. If Nishu is there, Nishu will answer. Okay. So there are 3 techniques are there: linear probing, quadratic probing and double hashing. Okay. Let's complete linear probing. Okay. Let's complete linear probing. So first of all, in closed hashing, the collided key collided key is stored within the table at different location. So no outside, no extra space. Because you don't know modulo, simple. You don't know how to compute the modulo operation, right? Modulo operation is when you divide, let's say 33 I am dividing by 9, go to the old method of dividing. Then how many times it will go? So 9, 27, because 4 times is 36. So 3 times it will go. So what is this? 3, 9, 3 are 27. So now if you look at this, then you will get 33 minus 27 is 6. Now this is your modulo. This is your result of modulo. Remainder you have to count. Okay. So I think you are getting quotient. Are you getting 3? 33 divided by 9. Are you getting 3 in these cases? I think you are looking at quotient. 3 is quotient. This is called quotient. No. We need to see remainder. Remainder is our answer. This is the remainder and this is the result of modulo. Okay. And that's why you are not getting correct answer. There is only 2 things are possible. Okay. Chalo. Now let's come to the linear probing. Let's come to the linear probing. Linear probing. Probing means searching. Probing is a term where probing stands for searching, examining. Not even searching, examining. Examine. Okay. So linear probing. Okay. So when the first time when the key is mapped, when key is mapped, okay, in hash table, so first location that you examine is what? Then first location we examine or probe. Probe means just examining one after another, right? So first location, and that is called probe number 0 is equal to ℏk. Whatever function gives you remainder and all everything. If it is occupied, okay. Acha, now if it is collision occurs here, if collision occurs, then where you will go? Probe number 1. And what is probe number 1? Acha, ℏk. Okay. What is probe number 1? So probe number 1 will be ℏk. Listen it carefully. ℏk plus 1 modulo m. M is what? Size of the table. One more time modulo. M is size of table. M is size of table. Okay, so M is size of table. Now, if I say probe number 2, then it will be equal to h of k plus 2 modulus m. If it is, again collision occurs. Probe number 3, third location that you will examine is ℏk plus 3 modulo m. And if you generalize this situation, probe number I, ith probe, is equal to ℏk plus I modulus m. M is size of the table like in previous problems. Okay. M is size of the table like in the previous problem. Okay. So the general rule is that ith probe, the last one, is equal to ℏk original location plus I modulus m. This is theoretical. This doesn't make sense. Sir, no, not able to understand. Okay, not able to understand. So for that we need to take another example. Okay, for that we need to take the example here. Look at this example. Okay, linear probing example, and after that you will solve one question, then we'll wrap it up for today. Okay, I told you many things in 1 hour. I told you, though I have not gone into the details of, let's say, more detail, but I told you many things in 1 hour. Look at here how this will work. Remainder, okay, remainder, look at the remainder. 18 modulo 3, quotient 1, remainder 5. If no collision, very well, congratulations. If crash course helps you really in getting 532 rank, 532 score, very good, very nice. Chali. So now 18 modulo 5 is equal to, that is equal to 5, and 5 is free, so you put 18 over here, no issue. 41 modulo 13, that is equal to 2, look at the remainder, 2 is empty, so you put 41 over there. Okay, no collision till now, prob 0 is successful. 22 modulo 13, so that is 9, okay, 9 is free, so you put 23 into this. 44 modulus 13, so that is equal to 5 is free. Now see, collision occurs. Okay, collision occurs in 44, original location is 5. What you have to do? You have to go for prob number 1. Prob 1 is equal to what? HK plus 1, or modulus, what you will do in this case is 13. So original location is 5. After that 5, this will not look good. So 5 linear probing means, let's keep it simple, apart from the formula. 5, then the next location I will set plus 1, 5 plus 1. So in this case this is free, so we will put 44 over here. Look at carefully, very simple. Okay, very simple. 59 will go to the 7th location, 7 is free, so I will put 59. Okay, so 5, then it goes to 6. 32 will be at 6th position. 6th position is occupied. Okay, so now linearly search the next empty position. 6 then 7 occupied, 7 then 8 not occupied. So that is equal to 32. Okay, so 6 then 7 then 8. So here I will write the sequence: 6 then plus 1 then plus 1. 31 will go to the which position? So 5th position. Okay, 5th position 31 will go. Now look at here, 5th is occupied, 6th occupied, 7 occupied, 8 occupied, 9 occupied, 10 is free. Okay, so 10 we will fill with the value 31. 10 we are filling with the value 1. 5, 6, 7, 8, 9 all are occupied. So 5 to we go to 6 occupied, 7 occupied, 8 occupied, 9 occupied, and finally settled in 10. 73, 65 plus 8. So original location is 8. 8 is what? Occupied. Then 9 occupied, 10 occupied. So 73 will settle here. Okay. So 8 to 9, 9 to 10, and 10 to 11. Okay. Now it settled here in this cases in 73. This is your linear probing, where you see the single entry, you will find the element in that particular place, that you will find 18 in 5, 41 in 2, 22 in 9, 22 in 9th location. 44 you will not in actual location is 5, but it will go to 6. 59 7, so it is free, 59 you will find. 32 original location is 6, occupied, then 7, then it will come to 32, so 8. Similarly 31 and 73. Okay, testing time. Okay, testing time. So testing time starts here, and I ask you very simple question. Where it will go, I will give you one homework, then we'll stop the today's session. Okay, tell me what is the answer for this question. Direct question, linear probing. What is the answer? uh, Chetan, what you do is, those who are selecting in the internship, okay, you look at their resume. You look in their resume what they are writing, so that they are getting selected and you are getting rejected. Compare your resume with those who are getting the internship. Great. Now, what is the 43 and its modulo 10? So 43 will go where? 43 will go to 3. Okay, 165. Definitely 165 will go to 5. 62. So 62 will settle in second position. Okay. 123. So 123 is occupied. So it will go to the next position, 123. Then comes 142. 142 will settle here. So 140 will be in the 2. Okay, then 3, then 4, then 5, and 142 will settle here. Okay, and that gives you the answer here in this case is D. D is the answer for this. So now here keys are given to you. Keys are given to you, and you need to identify the table. Okay, keys are insertion sequence is given to you, and you have to find out the table. Let's complete one more problem. I think we can do it. Okay, we can do it. The question is, table is given to you. Okay, table is given to you, you have to find insertion sequence. Table is given, you need to find insertion sequence. Can you do this?
No. 1.
It is not, we don't apply modulus operator for real numbers. Why? Why, sir? Why don't we apply modulus operator to a fraction? Achha. Sir, how do you find? Achha. Achha, sorry, wrong reading. Sir, how do you find mod in a fraction of second? Nothing, no great in this. I've been doing for long period of time, nothing else. It's just that I'm doing it many number of times, I remember everything. Table is given, you have to find insertion sequence. आइए, तो वी गॉट सम आंसर हियर और फाइन, लेट्स सी, लेट्स सी, लेट्स सी. Okay, now let's see the sequence one after 46. 46 will go to the 6. Table is in making. 42 matches. Table is in making. 34 table correct only. 52 will settle here. 52, then it will come to the in position. A cannot be the correct answer. A cannot be the correct answer. 52 will go here and then it will come to the third position, but third position is 23. A is not correct. Okay, A is not correct. Look at B option. So A is not correct. 34, okay, fine. 42 correct. 23 correct. 52, look at 52. So 52 here, occupied, occupied, occupied. So 52 here. Then it's a 33. Okay, then it's a 33. 33, 33, 33, 33. 33 here. Mismatch. Not correct. C, B is not correct. A is not correct. B is not correct. What about C? 46. 46 is correct. 34. Correct only. 42. Correct only. 23. Correct only. 52 will settle here, correct only, and 33 will be in the third, then 4, then 5th, then 6th. 33 will settle over here. Answer is C. No need to check D because only MCQ question was here. If MSQ, we have to check D also. Okay, if MSQ, we need to check D also. Thank you very much, guys. That completes your data structure and C programming. Thank you for a lovely interaction that I had and still having with all of you. Best of luck. Okay, best of luck. Keep learning and keep hustling, and I hope next time whenever we'll start the session in English channel, I will come. Just go through all the gate question. They are all are homework question will be there. Homework question will be there, but I solved it actually. I got the time, so I solved it. Anyway, no issue. Homework question will be here, and homework question I can show you that some little bit of challenge. How many insertion sequence are possible? Same question extension, that how many insertion sequence are possible. Okay, if you get doubt, then put in the Telegram. Okay, put in the Telegram group. This is the you can later take the screenshot or you can go backward. This is my link, t.me/ no classes. No classes tomorrow. Crash course is enough for it gets but you will not get through. It depends. We'll cover the content. Definitely crash course entire content is not covered. But is it enough? So if you have some fundamental basic idea, you can definitely make something out of it. Outcomes are possible with crash course as well. Chalo, bye everyone.